Welcome back to another deep dive. And, we know you are probably just drowning in the daily hyped up noise of the tech world right now.
Oh, absolutely.
It's just every single morning there is a new press release, right? A new benchmark. Some CEO getting on stage claiming their new system is going to, I don't know, change the fabric of reality.
Yeah, the marketing spin is just relentless.
It really is. It's exhausting. And quite frankly, it is really hard to know what is actually real and what is just, smoke and mirrors. So today, our mission is to just cut straight through all that noise for you.
Right, we're bringing the actual receipts today.
Exactly. We've got our hands on a definitive ground truth document. This is Mozilla's inaugural State of Open Source AI 2026 Volume 1.01 report. And this just dropped in July 2026.
It is a massive stack of data.
Massive. And we're going to use it to figure out why open source AI is basically dominating the world's actual workload, but at the exact same time, completely failing to make it into enterprise production.
Which is such a wild contradiction when you think about it.
It is. It reminds me a bit of the smartphone market from a few years ago. It wasn't that long ago. That if you wanted a smartphone with a truly great camera the kind that takes those impossibly crisp, low-light photos, you really had no choice.
You had to buy the flagship.
Right. You had to go to the store and shell out over $1,000 for the absolute top-tier model from one of the two big tech giants. There was this massive, undeniable gap between the premium stuff and literally everything else.
Yeah, I mean, the mid-tier phones would just give you these blurry, grainy photos. The compromise was incredibly obvious to anyone who looked at the results.
Exactly.
But then the frontier of capability just kind of commoditized. What used to be highly exclusive became standard. The supply chains optimized, the sensors got cheaper, and the software really caught up.
And suddenly you could buy a mid-tier phone for a third of the price that took pictures so good, you honestly couldn't tell the difference unless you were a professional photographer pixel peeping on a massive monitor.
Right, zooming way, way in to find a flaw.
Yeah. And that is exactly what this Mozilla report reveals about the current state of AI. That gap between the insanely expensive closed-off flagship models and the open, accessible mid-tier. It hasn't just shrunk. It's functionally disappeared.
It really has. And what's fascinating here is that this report proves this isn't just a conversation about code or model weights anymore. The technical problem of making AI smart, that is largely solved.
Which is crazy to say out loud.
It is, but it's true. The conversation has completely shifted to economics. It's about the brutal reality of deployability. We are looking at a massive systemic power shift in the technology sector right now.
A total shift.
Yeah. And the core paradox that this Mozilla data reveals, and what we're going to spend our time dissecting today, is this. Open source is winning the usage war by an absolute landslide. It is dominating the actual computational volume of work being done globally.
Right.
But simultaneously, organizations are spectacularly failing to actually deploy it into their own production environments.
It's a total contradiction. They are using it, but they can't deploy it. Okay, let's unpack this, because I want to look at how we even got to this point, since the timeline is just incredibly compressed.
Well, the speed is unprecedented.
Yeah. The report walks us through 4 distinct eras, starting back in 2023. And for those of you listening who are trying to build with open source back then, I'm sure you remember the absolute pain of it.
Oh, yeah. The report calls that the Llama 2 era, and it is very blunt about it. It basically says, look, that experience was real, but it is also 2 model generations old.
Right. Ancient history in AI terms.
Exactly. In 2023, if you tried to use open source for a serious business application, you ran into severe quality issues. The models hallucinated constantly.
You couldn't trust them at all.
No, not at all. If you tried fine-tuning them for specific enterprise tasks, say reading your internal legal documents, it usually just ended in total failure. They couldn't hold the context.
The data shows that developers would try it, get incredibly frustrated by the terrible outputs, and ultimately just revert back to renting GPT-4 through an API. It was an experiment. It wasn't a solution. It felt like playing with a toy.
But then 2024 hits. The Llama 3 era.
Okay, yeah.
This is when the fundamental capabilities took a major, major leap forward. We saw significantly better reasoning capabilities and much larger context windows. For the first time, open source wasn't just a hobbyist toy anymore.
It was real.
Right. It became a real, viable alternative for certain commercial applications. You could actually trust it to write basic code or summarize documents without hallucinating wild falsehoods every third sentence.
Which perfectly set the stage for 2025.
Yeah.
The report calls this the DeepSeek era. And this is when the ground really started to shake.
Definitely.
The open models achieved near parity with the closed frontier, but with significantly lower costs and incredibly strong economics. The open ecosystem didn't just become viable, it became ruthlessly competitive.
And that brings us to where we are right now, in the summer of 2026, the era of production scale. According to the Mozilla data, we are seeing enterprise adoption at a massive scale, to the point where open models are now powering roughly 33% of all tokens routed.
A third of all tokens.
Yeah, it has matured into a fully fledged commercial ecosystem.
So to really understand this 2026 landscape, we have to look at the leaderboards. But I know these benchmark names can sound like absolute alphabet soup to most people.
You really do.
Walk us through how the report actually measures this, because they cite something called the Artificial Analysis Intelligence Index, version 4.1.
Right, so the Artificial Analysis Intelligence Index is essentially a composite score. It is made up of 9 different, highly rigorous evaluations. And these aren't the basic high school tests models used to take a couple years ago.
Right, not just passing the bar exam anymore.
Exactly. We are talking about tests like Terminal Bench 2.1, Humanities Last Exam, and GPQA Diamond. These are designed to actively break models. They push them to their absolute limits in logic, multi-step reasoning, and highly specialized PhD-level domain knowledge.
Okay, so this is the ultimate gauntlet. And when you look at the chart in the report, the top 3 models in the world are still closed. Proprietary systems.
They are, yes.
You have Anthropic's Claude Opus 5 at the very top with an index score of 61. Right behind it is Claude Fable 5 at 60, and OpenAI's GPT 5.6, so at 59. But then sitting right there at number 4 is an open weight model.
Kimi K3 from Moonshot.
Yeah, Kimi K3. What does it score?
Kimi K3 scores a 57 on this composite index.
Let's just translate that for a second. That is just 4 points off the absolute frontier of Claude Opus 5. 4 points.
It's incredibly close.
And it's not a fluke, right? If you look at the top 11 models on this list, 3 of them are shipping open weights. You've got Kimi K3, you've got GLM 5.2 from Zipu, and MuseSpark 1.1. Kimi K3 is actually outperforming massive closed models from just a few months ago, like Claude Opus 4.8 or GPT 5.6 Tera.
It even beats Grok 4.5. And if we connect this to the bigger picture, it fundamentally changes the narrative of AI development, because we also need to look at the Epoch Capabilities Index, or the ECI.
Look what's out.
The ECI tracks these models by their release date, and the data in the report confirms this exact same dynamic. The absolute closed frontier, which in this specific index is GPT 5.6, sits at 162 points.
Okay.
The best open model, again Kimi K3, sits at 156.
So a gap of exactly 6 ECI points. I look at that and think, well, okay, 6 points is still a lead. The closed labs are still winning the race.
They are winning, but it is vital to understand what that number actually represents in real time. A 6-point ECI gap is not an insurmountable chasm. In historical terms, it represents roughly one single release cycle.
Oh, wow. One cycle.
Yes. Furthermore, if you look at the statistical error bars in the Mozilla report, the 90% confidence intervals for these models actually overlap.
Wait, really? So statistically speaking, depending on the specific test run or how the prompt is phrased, you could almost call it a tie.
The gap is literally that narrow, but the broader implication is even more profound here.
How so?
For a long time, the assumption in the tech industry was that the companies building closed models had a durable, compounding lead.
Right, the moat.
Exactly. The idea was that because they started first, built the biggest data centers, and had the most compute, their advantage would just grow and grow exponentially.
Yeah.
A flywheel of intelligence.
Yeah, that they would just pull away from the pack forever.
Right. But this data proves that theory completely wrong. Frontier capability behaves less like a permanent compounding advantage and more like a temporary position that gets completely reset every single release cycle.
I love that framing. It actually reminds me of playing a racing video game. You know when you were in second place and you are trailing the leader?
Like Mario Kart.
Yeah, exactly. You aren't running a completely different race. You are actually drafting right behind them. You are maybe one lap back or just a few seconds behind, but you are perfectly tracing their slipstream.
You see all their moves.
Right. You get to watch the optimal path they take around the corners. You see where they brake. You see where they crash. Open source isn't reinventing the wheel here. It's a ghost car drafting the closed models.
That is an excellent analogy.
They capitalize on all those research architectures that the closed labs spend billions of dollars proving, and then they just close the gap almost instantly.
And because open source is drafting so closely, the concept of a single uniform frontier is completely outdated now. The report explicitly describes the current state of AI as a jagged frontier.
A jagged frontier. I want to spend some time here because this is where the rubber meets the road for you, the listener, if you are actually using these tools for your job. The report breaks down workloads into three distinct zones. First, you have areas where open models are actually leading or at parity with the closed models. And the big one here is front-end coding.
This is a major validation for the open ecosystem. On El Marina's Front-End Code Arena, which is this platform where blind human developers vote on which model writes better website, and UI code Kimi K3 debuted at #1.
#1 outright.
Outright. It achieved a 1679 ELO rating. It took first place in 6 out of 7 front-end domains.
That's incredible.
It is demonstrably better at this specific highly valuable task than the most expensive proprietary models on the market.
And for anyone unfamiliar with ELO ratings, it's the exact same system they use in chess to rank players based on win-loss records. So developers are literally side-by-side comparing a website built by GPT 5.6 and a website built by K3, not knowing which is which.
Right, completely blind.
And they are choosing K3 more often, which is just wild to think about. But then you move to the second zone on this jagged frontier, which the report calls the contested zone. This is agentic terminal work.
Right, and agentic terminal work essentially means giving the AI access to a computer terminal, just like a human programmer would have.
So it can actually do things, not just talk.
Exactly. You ask it to execute multi-step programs, fix bugs in a repository, or run complex research tasks autonomously. On Terminal Bench 2.1, Kimi K3 scores an 88.3, and the closed GPT 5.6 Sol scores an 88.8.
So it's basically a dead heat.
It is a dead heat. K3 actually wins on specific benchmarks like Program Bench and Spreadsheet Bench 2, but it loses slightly on Frontier SWE, which measures resolving real-world software engineering tickets.
So it's a back-and-forth battle depending on the exact nature of the agentic task.
Precisely.
But then we get to the third zone, the closed edge. This is where the proprietary models still earn their premium price tag, and the report defines this as professional knowledge work.
Yes, and this is measured by benchmarks like GDPval AA version 2, which looks at expert-graded professional tasks.
It's like what kind of tasks?
Think of highly complex legal analysis, sophisticated financial modeling, or drafting regulatory compliance documents. This is where Claude Fable 5 pulls ahead of Kimi K3 by a significant 92 ELO points.
Oh, why?
Yeah, it's the largest separation we see across the shared benchmarks.
So if I'm feeding both of these models a massive amount of data, what exactly is the closed model doing better under the hood? Why is it winning there?
It really comes down to deep, sustained reasoning over very long context windows.
Okay, explain that.
If you feed a model a 500-page legal document and ask it to find a highly nuanced contradiction on page 412, the closed frontier still maintains higher fidelity. Open models tend to, well, lose the plot slightly faster when the context window gets stretched to its absolute limits.
They kind of forget what they read at the beginning.
Exactly. Additionally, there is a factor of conversational polish. Even Moonshot, the creators of K3, can see that the user experience, the formatting, and the raw conversational elegance of their model still trails the closed frontier.
The bedside manner just isn't quite there yet.
Right? It's a bit more robotic.
So what does this all mean for you, the listener? If you are a developer or a product manager using AI to generate boilerplate code, build web interfaces, or even run automated agent workflows, you do not actually need to pay the premium for the closed frontier anymore.
No, you really don't.
If you do, you are basically paying for a flagship camera to take a picture of a grocery receipt, right? The rule of the jagged frontier is simple: match the model to the job. And for a huge chunk of commercial jobs, open models have already cleared the bar.
And that realization is causing a tectonic shift in the economics of the industry. Because once performance is at parity, or even just good enough, the only axis left to compete on is price.
Right. So if these open models are nearly tying the proprietary giants in raw intelligence, my immediate assumption is that they must cost roughly the same to run. I mean, the compute required to generate that intelligence should be a fixed law of physics, right?
You would think so.
But the data shows the exact opposite. Let's look at the token economy, because these numbers are honestly hard to wrap your head around. The report tracks the inference costs for models operating at what we would call GPT-4 class performance.
Meaning models that are as smart as the original GPT-4 was when it launched back in March 2023.
Right. When GPT-4 launched, the blended API list price was $20 per 1 million tokens. Well, wait, originally it was $45, then dropped to $20 with Turbo.
Right, it came down a bit.
But look at where we are in December 2025. The cost for that exact same level of intelligence is 40 cents per 1 million tokens.
40 cents. It is a staggering 50 times drop in inference costs over just 36 months.
A 50 times drop. I mean, how does that even compare to other historical technology booms? Because we've seen tech get cheaper before.
We have, but what's fascinating here is that this completely shatters historical technological cost curves. The Mozilla report contextualizes this beautifully. If you look at the historic PC compute curve, the steady march of Moore's lawmaking processors cheaper and faster,
Yeah, the classic benchmark.
over a similar 36-month period, PC compute delivered a 3.4 times drop in cost.
Okay, 3.4.
If you look at the dot-com boom, the historic curve for internet bandwidth cost delivered a 2.6 times drop over 36 months.
So PC compute drops 3.4 times, internet bandwidth drops 2.6 times,
Right.
and AI inference drops 50 times.
50 times. It is an order of magnitude more aggressive than the defining technological shifts of the last 40 years. And it's crucial to understand why that price crashed so violently. It wasn't the closed labs voluntarily deciding to lower their profit margins out of the goodness of their hearts.
Definitely not. It was open source crashing the floor.
Exactly.
The chart shows it perfectly. In July 2024, Meta released Llama 3.1, and in a single quarter, the floor price plummeted by 11 times, down to 88 cents. And then DeepSeek entered the chat and drove it down even further.
And this cost collapse isn't just happening for standard conversational models. It is happening at the very edge of complex reasoning. The report compares DeepSeek R1, which is an open model released under an MIT license in January 2025, against OpenAI's proprietary O1-1217 reasoning model.
Just to clarify for everyone, these are the models designed to stop and think before they answer, right? The ones that generate internal chains of logic before spitting out a final response.
Correct. They reason through the problem. On the Math 500 benchmark, both models score roughly 97%.
Basically perfect.
Yeah. And on the AAE Poodle 24 pass at one benchmark, which tests incredibly difficult mathematics that even elite human math competitors struggle with, both models score roughly 79%. They are practically identical in their reasoning capability.
But the price difference is absurd. DeepSeek R1 costs 55 cents per million input tokens. OpenAI O1-1217 costs $15.
$15 versus 55 cents. It is roughly a 27 times price gap for identical reasoning scores.
That is just, that's game-changing.
And by April 2026, DeepSeek V4 Pro drove that input price down even further to roughly 43 cents per million tokens, while expanding to a 1 million token context window. The cost of raw intelligence is effectively approaching zero.
But hold on, I want to push back on this a bit, because the report breaks down usage by two different metrics, right? Requests and tokens. And the story they tell is completely different.
It is, yeah.
If I'm looking at the market by requests, the closed US-based providers are still winning. Google alone captures 28.7% of requests. Anthropic and OpenAI combined have about 20%. So the closed labs are still dominating the actual interactions, aren't they?
This raises a really important question about how enterprise AI has evolved, and we have to define what these metrics actually mean in a business context.
Okay, let's define them.
A request is simply a single interaction. You ask a chatbot to write an email, it rates the email. That's one request. A token, on the other hand, is a piece of a word. It measures the actual raw volume of data being processed.
So length and density.
Exactly. If you ask a simple question, that's one request and maybe 50 tokens. But if you point an AI at a repository of 1 million internal log files and ask it to find security vulnerabilities, that is still technically one request, but it processes millions or even billions of tokens.
Okay, so a request is just pulling the trigger, but tokens are the actual bullets being fired.
That's a very good way to look at it. Requests represent the legacy stronghold. They represent human beings sitting at keyboards, typing into chat interfaces. It's consumer behavior or light office work.
Like me asking for a recipe.
Right. Tokens, however, are the leading indicator of the future because they represent automated machine-to-machine workflows. It's heavy coding, it's agentic systems running in the background all night, it's massive batch processing of documents.
And when you look at the tokens, open source is completely dominating. The report looks at data from OpenRouter, which routes massive amounts of AI traffic. Back in November 2024, OpenWeights routed only about 2% of all tokens.
Almost nothing.
Right. But by November 2025, that skyrocketed to 33%. And if you look at the top 20 models by routed tokens in July 2026, the data is just stark.
The top 7 highest volume models in the world all ship open weights. You have Xiaomi's MiMo V2.5 at number 1, capturing nearly 18% of the top 20's tokens all by itself.
Wow.
Then you have DeepSeek V4 Flash, Tencent's H2i3, Minimax M3, Zippo's GLM 5.2, DeepSeek V4 Pro, and NVIDIA's Nematron 3 Ultra.
Crod Opus 4.8 doesn't even show up until number 8 on the list. The open models in the top 10 account for 72.4% of the total token volume. The closed models in the top 10 account for just 8.7%.
It's a complete blowout.
When you aggregate the monthly tokens, Chinese-built open models are routing roughly 82 trillion tokens a month, compared to U.S.-built closed models routing roughly 23 trillion. That is a greater than 3.5 to 1 ratio.
Because you don't use a highly expensive closed API to process 10 million internal log files. Use a cheap, fast, open-weight model. Open source dominates the industrial application of AI.
Okay, so if I'm listening to this, I'm thinking, wow, open models are incredibly smart. They are practically tied with the frontier. They're almost entirely free to download. And they're already dominating the actual volume of work being done in the world. It sounds like an absolute utopia for developers.
It does sound like that.
So why did you say at the very beginning of this deep dive that organizations are spectacularly failing to deploy them? Why is everything stalling out?
Because downloading the intelligence is the easy part. Serving it to thousands of concurrent users in a secure, stable production environment is a nightmare. We have to differentiate between the open frontier and the deployable open frontier.
The deployable frontier. The report outlines this adoption funnel, and it really looks like a leaky bucket. 89% of firms are using open components somewhere in their stack. 79% of developers report using open models.
High usage.
Right, but when you look at how many of those open models actually reach a live production environment, it drops to just 51%.
Compare that to closed models, which successfully reach production 63% of the time. The friction is clearly heavily concentrated on the open side.
And it gets even worse when you look at how they are deploying. If an enterprise partners with a specialized vendor to handle the deployment, they hit production 67% of the time. But if an internal IT team tries to build the infrastructure and deploy it themselves, they only succeed 33% of the time.
They fail 2 times out of 3.
And the most damning statistic of all, out of all these enterprise pilots, only 5% can demonstrate a measurable financial impact.
This is the crux of the issue. The gap is purely operational. It is about hardware and infrastructure. Let's break that down with a real example from the report. Let's take Kimi K3, the model that is practically tied for the best in the world. You can go to the internet and download the weights right now.
Just click download.
Right. But what does it actually take to run it?
Let's get into the weeds here, because I think people assume you just put it on a server, double-click an icon, and hit run.
I wish it were that easy. To run Kimi K3 in production using native MXFP4 precision, you need a minimum of 64 accelerators. That translates to roughly 8 GPU nodes. And it requires 1.4 terabytes of memory just to load the model, let alone serve multiple concurrent requests.
Wait, before we talk about the 64 accelerators in XFP4, for anyone who isn't a hardware engineer, we're basically talking about how tightly you can compress the model's brain without it getting stupid.
Exactly. Quantization, or lowering the precision, is like taking a high-resolution image and saving it as a smaller JPEG.
Okay, I get that.
You lose a tiny bit of detail, but it takes up way less space. MXFP4 is a highly efficient 4-bit data format designed to compress these massive neural networks so they can run faster and use less memory. But even fully compressed into this highly efficient format, K3 is still so gargantuan that it demands 1.4 terabytes of memory.
8 massive server nodes.
Yeah.
Just to turn the thing on.
Precisely. Now compare that to a model like Inkling, built by Thinking Machines Lab. It's a US-built model released under an Apache 2.0 license, and it is specifically architected to fit on a single node.
Just one.
Right. It requires about 600 gigabytes or more, depending on the generation of the GPUs, but it straddles that one node line. Or look at GLM 5.2, which runs on reference INT4, another compression format, and fits cleanly on one node with about 577 gigabytes of memory.
So what does this all mean for the ecosystem?
It means that hardware constraints are actively dictating who can actually use the open frontier. The capability is democratized, but the compute is deeply centralized. The single 8 GPU node has become the definitive deployability line.
If you can't fit on one node, you're out.
Exactly. If your model doesn't fit on one node, you lock out the vast majority of mid-market and internal enterprise development teams. They simply don't have the specialized hardware clustering to run an 8-node behemoth.
To visualize this, the Mozilla report provides a fantastic stack map. They scored 9 different layers of the open source AI stack across 9 criteria, rating them from 1 to 5. And it perfectly illustrates this disconnect.
The top layers of the stack, the model code and the model weight, score incredibly high on capability. They average 3.96 and 3.67 out of 5. They score well on community support, ease of adoption, and performance versus closed models.
The science of intelligence is solved.
Right.
But then you look at the columns for standardization and enterprise readiness, and the scores just fall off a cliff. The overall layer for safeguards scores a miserable 2.64. The agent layer is at 3.04. The operational gap is a gaping hole in the ecosystem.
And there is a crucial, highly technical detail in the report that highlights just how fragile this operational layer really is. It involves the infrastructure standardization score, which barely improved from 3.1 to 3.4 over the last year.
Yeah, the report mentioned something about KDA class linear attention. Walk me through why this broke things.
Okay, so for a long time, the open source community relied on standardized serving engines, like VLLM. Think of VLLM as the traffic cop for GPU memory.
Okay, traffic cop.
If a model was built on a standard transformer architecture, VLLM knew how to load it, manage the memory, and feed it user requests efficiently. But as models push for greater efficiency, they changed their fundamental architecture. Kimi K3 introduced KDA-class linear attention.
What does that actually mean under the hood?
Traditional transformer models have to look at every single previous word they've generated to figure out the next one. If you write a 10-page essay, by page 10, the model is constantly looking back at page 1 to maintain context.
Which takes a lot of memory.
Massive, massive amounts of memory. Linear attention is different. It acts more like a running summary. It compresses the past information as it goes, so it doesn't need infinite memory to remember what happened on page 1. It is brilliantly efficient.
But I'm guessing that completely breaks how older serving engines were built to feed it data.
Exactly. Because the architecture changed so fundamentally, it broke runtime compatibility. VLLM, our metaphorical traffic cop, didn't know how to route the data for a linear attention model. Simply downloading the K3 weights no longer guaranteed you could actually serve the model.
That's a huge problem. So how did it get fixed?
Moonshot, the company behind K3, had to manually resolve it by contributing their specific KDA prefix caching code upstream directly into the VLLM project.
They basically had to rewrite the traffic cops manual and release it alongside their weights in late July.
Exactly.
But hold on, if the big hurdle here is just operational, if it's just about provisioning hardware and smoothing out software standards, shouldn't massive enterprises with practically unlimited budgets be able to fix this? I get why a small startup can't run K3, but why is this stopping the Fortune 500?
Because the data proves that money does not solve this problem. The report breaks down the share of adopters reaching production by organization size. For small companies with under 50 employees, the deployment rate is terrible. Across the board, 54% for closed models, 53% for open models.
They just don't have the resources.
Right. But look at the enterprise-tier companies with over 1,000 employees. Their success rate for putting closed models into production jumps to 73%.
Okay, that makes sense.
But their success rate for putting open models into production, it stalls out at 57%. So even with a massive IT budget and an army of engineers, they still can't get open models deployed reliably.
Wow.
Closed deployment is a problem that money solves. You pay OpenAI or Anthropic, they give you an API key, and the infrastructure, the hardware, the traffic cops, that is all their problem.
You just pay for the privilege of not caring.
Exactly. Open deployment, however, is a problem the entire ecosystem has to finish solving. No single enterprise, no matter how rich, can brute force a broken open standard or magically create enterprise-grade safeguard tooling overnight.
And this friction is causing serious churn. The report surveyed developers who actually abandoned open models. They tried them and then left. Why did they leave?
Well, the baseline challenges are the same everywhere. 27% cite high infrastructure or compute costs, and 26% cite security, privacy, or compliance concerns. That blocks adoption across the board.
But if you want to know what actively drives a developer away from open source, you have to look at the delta, right?
Right.
The difference in responses between developers currently using open models and those who churned.
Exactly.
The developers who churned were 12 percentage points more likely to say model performance is not good enough. They were 11 percentage points more likely to point to difficulty integrating into existing systems. And another 11-point jump for the burden of ongoing maintenance and updates.
They are essentially saying, It's too hard to connect to my database. It's a massive headache to keep updated. And after all that work, the performance doesn't justify the effort.
And this isn't an isolated regional issue, is it?
No, the report breaks down these challenges globally from North America to Greater China to South Asia to Western Europe. The heat map of their frustrations is nearly identical. Everyone, everywhere, is struggling with the exact same deployment bottlenecks.
It's universally painful. But despite all these massive operational headaches, despite the enterprise deployment rate stalling at 57%,
Yeah.
well, there is an ocean of serious money pouring into the open ecosystem.
Oh, yeah.
It is not slowing down because open source AI is no longer just a hobbyist endeavor managed by volunteers on GitHub. It has become a highly lucrative, multi-billion-dollar business model.
The revenue figures cited in this report are staggering, and they validate that this is a sustainable commercial path. Databricks is currently sitting at a $5.4 billion revenue run rate,
That is astronomical.
growing over 65% year over year, and they are reportedly weighing a capital raise at a valuation north of $165 billion.
And it's not just them. Mistral, the French AI lab, is generating $400 million in annual recurring revenue. That is up 20 times in just 12 months. DeepSeek, out of China, hit $220 million in ARR by mid-2025, mostly from API and enterprise customers, having raised $7.4 billion in venture capital.
What we are witnessing is the maturation of open source monetization. Historically, companies like Red Hat proved you could build a billion-dollar business by providing enterprise support for open source Linux. Today, the AI ecosystem has established 5 distinct, proven revenue models at scale.
Let's list them out because the report is very clear on this. 1, hosted inference, basically, doing the hard work of running the servers for the customer so they don't have to buy the 64 accelerators themselves.
Crucial service.
2, enterprise platforms, like what Databricks provides, which give you a clean interface to manage your data and models. 3, on-premise licensing for companies like banks that need total data security behind their own firewall.
Right, they can't have data leaking.
Exactly. 4, fine-tuning services, customizing the models for specific corporate data. And 5, harness tooling.
Harness tooling is exactly what we were just talking about. It's the software that sits above the model to make it actually deployable. The MLOps platforms, the serving engines like VLLM, the security guardrails.
If the model is the engine, the harness is the steering wheel, the brakes, and the chassis.
That's a great way to picture it. And venture capital is aggressively fueling this entire stack. We mentioned DeepSeek's $7.4 billion. Moonshot has raised $3.9 billion and is currently asking for a $31.5 billion valuation.
That's just wild.
Reflection AI has $2.1 billion. Cerebra's $2.1 billion. Thinking Machines Lab, the creators of Inkling, raised $2 billion and had a $12 billion valuation right around their July release.
It's a gold rush.
Yeah.
Pure and simple. But what I find fascinating is how developers are actually consuming all this funded innovation. Because they aren't picking teams. It's not a war between open and closed where one side has to lose.
No, it is an ecosystem of coexistence. The report highlights the rise of the hybrid developer. 78% of developers are now pairing specialized, task-optimized open models right alongside general-purpose closed models.
According to the Data survey within the report, 50% of developers use both open and closed models. 29% use only open models, and 21% use only closed models.
And crucially, developers are finding more distinct applications for the open models. Open models average 5.1 use cases per developer, compared to 4.6 for closed models.
So they are using the big, expensive closed models for the heavy, complex reasoning, and they are deploying swarms of cheaper, specialized open models for everything else.
Precisely. But if we want to talk about ironies in this landscape, we have to look at the corporate tech giants. Microsoft, Amazon, NVIDIA, Google, IBM, Meta. The incumbents.
They are playing both sides of the chessboard simultaneously. The report has this incredible diagram showing corporate participation. Microsoft is deeply partnered with OpenAI, but they're also directly invested in Mistral.
Right.
Amazon is pushing its own services but invested in Hugging Face. Google is shipping its open-weight Gemma models while investing in Hugging Face. IBM has Granite, Meta has Llama, NVIDIA is investing in Mistral. Together, Cohere, Fireworks, Basin, and Hugging Face, while also shipping its own Nematron models.
It is a massive hedging strategy. No one wants to be caught off guard if the proprietary API model collapses. So they are heavily subsidizing the open source alternatives to ensure they have a seat at the table regardless of how the market shakes out.
But despite all these billions of dollars sloshing around from VCs and strategic corporates, Your analysis of the funding stack reveals a massive structural flaw, doesn't it?
Yes, it really does. The Mozilla report visualizes the funding intensity across the different layers of the AI stack, categorized by where the money is coming from. Private VC and strategic corporates are pouring massive amounts of capital, scoring a 3 out of 3 into foundation models, inference and serving, and infrastructure and compute.
The engines, the hardware, and the hosting are fully capitalized.
Exactly. But then you look at the trust layer.
Okay, what's in the trust layer?
The trust layer consists of data and data sets, and safety evaluation and governance. Private VC funding for both of these layers is literally a zero.
Zero. They're throwing billions at the models, but nothing at the safety or the data quality. Why?
Because VCs fund hyper-growth revenue engines. Creating standardized safety evaluations or curating pristine, unbiased, open data sets is incredibly important for the ecosystem, but it doesn't generate 100 times financial return for a venture firm.
It's the boring infrastructure work.
Right. Consequently, the report shows that these critical trust layers rely almost entirely on government and philanthropic funding, scoring 1s, 2s, and 3s in those columns.
So the foundation of open source AI trust is essentially surviving on grants and charity, while the compute layer is swimming in billions. That feels incredibly fragile.
It is fragile, and it leads to a staggering asymmetry in the market economics. The report analyzed the model layer on Open Router between May and September of 2025. During that window, open models captured roughly 80% of the total usage volume.
80% of the work.
Yes. But when you look at the revenue generated during that same period, closed models captured roughly 96% of the revenue. Open models, despite doing 80% of the work, captured only about 4% of the revenue.
That is a mind-bending discrepancy. 80% of the usage, 4% of the money. How's that even sustainable?
It is sustainable because the cost of open inference is so low. But the value being generated for the end user is massive. The Linux Foundation estimates that this open-closed price asymmetry represents $24.8 billion in unrealized annual savings for the companies utilizing these open models.
$24.8 billion in savings. That isn't just a fun statistic. That is exactly why the legacy tech companies, the ones relying on expensive API subscriptions, are starting to panic. Which brings us to the breaking point of the modern AI economy, the collapse of the metered model.
This is perhaps the most consequential trend identified in the report. The token-based pay-as-you-go API model, which has been the default business model for AI since the launch of GPT-3, is fundamentally breaking at enterprise scale.
The report gives us 3 brutal case studies of enterprises colliding with token-based pricing. Case study 1, Microsoft. According to the report, Microsoft is canceling most of its Claude Code licenses by June 30, 2026.
Wow.
Why? Because the token billing consumed the division's entire annual AI budget in a matter of months. And remember, this is Microsoft. If they are blowing through their budgets on metered APIs, imagine what is happening to smaller companies.
Case study 2 is even more illustrative. Uber exhausted its entire 2026 AI coding budget in just 4 months. The data shows that individual engineers were billing between $500 and $2,000 per month on usage-based coding tools.
Per employee.
Yes. Uber had to step in and aggressively cap the spend at $1,500 per tool per employee.
This is like giving every single employee a corporate credit card to take a taxi to work. And it works fine for a little while.
Yeah.
But then you realize halfway through the year that they've all been taking helicopters to work because it's faster and makes them vastly more productive.
It's too easy to spend.
Right. You look at the bill and you realize you have to just go out and buy your own fleet of cars just to stop the bleeding. You can't rent helicopters by the minute forever.
That is a perfect analogy. You are describing the shift from variable expenses to fixed costs. When a tool is highly effective and increases productivity, employees will naturally use it more. But under a metered API model, every time an employee is productive, it costs the company money.
It penalizes productivity.
Exactly. When a tool becomes too useful to ration when you actively want your employees using it all day, every day, usage-based pricing fundamentally puts the vendor, not the customer, in control of the unit economics.
Which leads us to case study 3, the solution. Stripe. Stripe managed to cut its inference costs by a massive 73%
Coway.
by switching to open, self-hosted models. Let's dig into how they actually pulled that off, because it wasn't just flipping a switch.
No, not at all. The data is clear. If the close API cost index is baseline 1.00, Stripe's open self-hosted cost index is 0.27. They achieved this by serving 50 million daily API calls on the VLLM infrastructure, using just 1/3 of their GPU fleet.
They bought the cars. But buying the cars means you have to maintain them, right? What does transitioning 50 million daily API calls actually look like for an engineering team?
It requires a massive upfront investment in infrastructure. They had to provision the GPUs, integrate VLLM, ensure high availability so the system doesn't crash when traffic spikes, and build all the security routing themselves.
That's not trivial.
It is hard, complex engineering, but the payoff is immense. By owning the infrastructure and running open weights, they establish a fixed cost that the company actually owns. The GPUs depreciate on a known schedule. The electricity costs are relatively stable.
No surprise, helicopter bills.
Exactly. Most importantly, they can accurately forecast their AI spend for the next fiscal year. Owning the economics becomes mathematically mandatory over renting them when you hit scale.
And the report ends this section with what has to be the ultimate irony of the entire 2026 AI landscape. By June of 2026, Microsoft, the world's largest software company, the primary backer of OpenAI, was exploring using Azure-hosted DeepSeek V4 for its heaviest Copilot workloads.
It's incredible.
They were literally trying to route around their own partner's meter because the token costs were too high.
When the largest software company on Earth can't afford the metered API model for its own internal heavy lifting, the paradigm has officially shifted.
So let's summarize this journey. We started by asking where the open source AI ecosystem stands today, and the Mozilla report has given us a very clear answer. We aren't asking if open source AI is smart enough anymore. That debate is over.
Completely over.
The jagged frontier proves that it is practically tied with the best proprietary systems in the world. And thanks to the token economy, it costs an absolute fraction of the price.
The capability gap is closed. The price gap has widened to a canyon. The only remaining battleground is the deployment disconnect.
The real battle right now is at the harness layer. The operational tooling, the standardizations, the security frameworks required to take these massive, incredibly smart models and actually deploy them securely at scale inside an enterprise.
Which brings us to the core takeaway for you, the listener. If you are building a product right now, if you are prepping for a strategy meeting, or if you are managing a tightening tech budget, you need to adjust your focus. Do not get distracted by the daily press releases about the model capability wars.
Right. Don't worry about who is 2 ELO points higher on the leaderboard this week.
Exactly. Ignore the noise. Pay attention to who is fixing the deployment and infrastructure gaps. Watch the companies building the MLOps platforms, the serving engines, the enterprise safeguards.
Because the data clearly shows that is the actual bottleneck. Whoever solves the deployment friction is going to dictate the real winners of the 2026 AI landscape.
And as we wrap up, there is a final, slightly provocative thought I want to leave you to chew on. Something that this report hints at, but leaves unresolved.
Okay, let's hear it.
We talked about how deploying these new massive open models requires serious infrastructure engineering, like when Moonshot had to step in and manually rewrite the VLLM standard just to accommodate their new KDA architecture.
Right. It required a massive, highly skilled intervention just to keep the standard serving layer functional.
So here's the question. If fixing open source deployment is so complex that it requires that level of intervention, who actually controls the open standard?
Oh, wow. That's a good point.
If only massive corporations and labs with billions in VC funding have the engineering weight and the hardware to dictate how the serving layer evolves, are we actually decentralizing AI? Or are we just building a new, slightly more transparent oligopoly where a few giants still pull all the operational strings?
Yeah, it is a vital question. A model is only truly open if the community actually has the practical ability to run it, modify it, and govern the infrastructure it sits on. If the harness becomes a new proprietary moat, then the open weights themselves might just be an illusion of democratization.
Precisely.
It brings us right back to where we started. The cameras on the mid-tier phones got just as good as the flagships. The capability commoditized. But it didn't change the fact that only 2 massive companies still control the entire operating system ecosystem that the cameras actually plug into.
The hardware caught up, but the power dynamics just shifted to a different layer of the stack.
We'll leave you to think about that. Thanks for joining us for this deep dive. See you next time.